Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Dining Car by Katie Splendor, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. We have German whispers, or as I like to call them, whisper 5 lines, because a setter came up with that naming convention that is different, and it makes more sense because it's very easily extendable. Where neighboring digits on a green whisper 5 line must differ in value by at least 5. So for example, if this were say a 3, this would have to be an 8 or a 9, because the only digits which are 5 or more away from 3 are 8 and 9. And that's an example of how a whisper 5 / German whisper line works. We have even lots, where a digit in a gray square indicates how many even digits appear along the German whisper line it is attached to, or the whisper 5 line that it's attached to. So, say this was 3, 9, 2, well, that's not going to work. 3, 9, 1, nope, that's not going to work either. Let's just use this one. This will be easier. So we have 4, 9, 2, and 7. And this would be valid because the even lot here, the digit in the gray square, indicates how many even digits appear along this whisper 5 line it's attached to. So that's an example of how the even lot works. We also have XV sums, where digits separated by an X sum to 10, and digits separated by a V sum to 5, and there is no negative constraint. So for example, if this were say a 3 here, this would have to be 7 to add up to 10. If this were say a 1 here, this would have to be 4 to add up to 5, because there's a V between them. And that's an example of how XV sums work. And finally, we have ratio crop keys, where digits separated by a black crop key dot have a ratio of 2 to 1. There is no negative constraint. So, for example, if this were a 3, this would have to be a 6, because these two digits must be in a 1 to 2 ratio with each other. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, first things first is well, along these even lots, there are going to have to be, well, at most you have the number of digits along the whisper 5 line, right? So this is 1 through 4. This is 1 through 4. And these could be up to 6. But the problem is that, first of all, this digit is in a 1 to 2 ratio with 2 unique digits. Now, the only possible combinations are 2 and 4 to be in a 1 to 2 ratio with 2 unique digits. 2 can be in a 1 to 2 ratio with 1 and 4, and 4 can be in a 1 to 2 ratio with 2 and 8, right? But 4 on a whisper 5 line can only be next to one unique digit on the whisper 5 line, and that's 9. So therefore, this can never be 4 here. Therefore, this must be 2. And 2 means there's 2 even digits on this whisper 5 line. Well, 2 is in a 1 to 2 ratio with 1 and 4. Again, 4 cannot be next to 2 unique digits on a whisper 5 line. It can only, wait, that doesn't, yes, it only can be next to 1 unique digit on a whisper 5 line. So this can't be 4 here, it's 1, which makes that 4 there. So we have 1 even digit on this whisper 5 line. Here we have 2 even digits on this whisper 5 line. Also, this ratio here to add up to 5 must be 2 and 3 because we can't have 1 here. So this is a 2-3 pair here. 1 can only be next to 6. Well, okay. On a whisper 5 line, you'll always alternate between low digits and high digits. And the reason why you know that is take a look at and low digits being 1 through 4, high digits being 6 through 9. And the reason why you know that is just take a look at what digits can be next to a low digit. Well, you have 1 through 4. 1 can be next to 6 through 9. 2 can be next to 7 through 9. 3 can be next to 8 or 9. And 4 can only be next to 9. And which are all high digits. So next to a low digit must be a high digit. Well, what about the high digits? 6 can be next to 1. 7 can be next to 1 or 2. 8 can be next to 1 through 3, and 9 can be only next to 1 through 4, which are all low digits. So next to a high digit, you must have a low digit. So these digits in the central box have to be all high digits next to the low digit. And it's the same with these, actually. So then we can maybe we could have done this in the beginning. We color these high, high, and low. So this is a low, guaranteed. This is a low, guaranteed. So is this, which means next to it are highs. So these are highs, and these must be lows. Well, there are multiple. So 4 is also a low here. In these digits, these are all the high digits in the central box because you only have 4 high digits, right? 6, 7, 8, and 9. So therefore, where's the 6 in this box? It can't be next to the 7. It has to be next to the 1, but it can't be next to a 2 or 3 here. So this can't be 6, which means 6 has to be here, which must be next to a 1 on the whisper 5 line. So that's 1 there. And we have our even digit on this whisper 5 line. So this can't be even. This is odd. That's 3. That's 2. That leaves this as 7 or 9 here. And this must be 7 or 9 here. This is a high digit, which is next to a low digit to add up to 10, right? Because if you have a 6, 7, 8, or 9 to add up to 10, it must be with 4, 3, 2, or 1. So this has to be low here. This 1 eliminates 1 here, so we have at least 2. We can't have 4. Okay, we have at least 2 even digits here. And we can't have 4. This is a low digit. It cannot be 1, 2, or 4. Therefore, this must be 3. So this is 3 here. If we had a 4 here, that would guarantee a 9 here and a 9 here, and therefore you would not have 4 high digits, or sorry, 4 even digits on this line. So this can't be 4. That's 2. It's the same thing here. This can't be 4. Because we can't if there's a 4 here, well, first of all, it can't be between 2 unique digits on a whisper 5 line, so that doesn't work. 3 is next to 6 here, which is a high, which has to be adding up to 10 with 4. These are low, and this is a 3. We have a 1 and 3 here. 7 can't be next to a 3 on a whisper 5 line because it's only 4 apart. So this must be 9 here. That leaves the remaining high digits in the central box as 7 and 8. And the remaining digits here have to be 3 and 5 as a pair. Okay. This must be low. These two must be low because of low digits there. They're next to high digits, and therefore this must be high. This digit cannot be 1 or 2, and it's next to a 7 or 8 on a whisper 5 line. Excuse me. So it cannot be 4, which makes this a 3. So this is 3, this is 6. To be in a 1 to 2 ratio. This cannot contain 1, 2, or 3, so this has to be a 4, 8 pair here to be in a 1 to 2 ratio. Okay, this can't be 2, 3, or 4 because of 2, 3 in the box and 4 in the row. So this digit must be a 1 here. This digit can't be 1, 4, or 3 because of the 1, 4 in the row and the 3 in the box, and it's a low, so this must be 2 and 8 here. We have 2 even digits now on this Whisper 5 line, so this can't be even because we have to have 2 specifically. So this cannot be, this has to be an odd digit, and it must be next to 2 and 3, so therefore it must be 9. This is a high digit, which is in a 1 to 2 ratio with another digit, which must be low. So this must be 6 or 8 here. If this is 8 here, this is 4 here. If this is 6 here, that's 3. And this 4-8 pair is eliminated because that would, if we had a 4-8 pair here, that would eliminate all possibilities for that cell. So this must be 3 and 6 here, which means this is guaranteed to be a 1 next to it on the Whisper 5 line. So there's only one even digit on this Whisper 5 line. So this can't be 1, and it can't be 2 or 4 because those would be even, so this must be 3 here. 3 can only be next to 8 or 9 on a Whisper 5 line, and 9 is the only odd digit. And since we have already one even digit on this Whisper 5 line, this must be odd, and it's 9. Same with this Whisper 5 line. We already have 2 evens in the 2 and the 8. So that means we cannot have another even digit on those Whisper 5 lines. So this can't be 9. So this must be 7 then. So we have 7 and 9 there. 3 is in a 1 to 2 ratio with 6. 3 adds up to 10 with 7. So this can't be 7, that's 8. Well, we already knew that because 3 cannot be next to 7 on a Whisper 5 line. 3 eliminates 3 here, so that's 5 and 3. 1 to 2 ratio here does not have a 1, does not have a 3, so we're guaranteed a 4, and it can be with either with 2 or 8. 2 can't be here because of 2 in the row. So 9 eliminates 9 here, so that's 7. And the rest is just normal Sudoku. Okay. Where should we start with a normal Sudoku? We do have 6 digits in columns, so let's do that. I feel like I'm gonna sneeze. Excuse me. In column 4, we have 1, 2, and 4 remaining, and this can't be 4 here because of 4 in the box, so 4 has to be here, which leaves a 1, 2 pair in the rest of the column. In column 6, we have 2, 5, and 8 remaining. 2 can't be here because the 1, 2 pair in the box, so this is 5 or 8. That leaves this as 2, 5, or 8, 2, 5, and 8. And 4 eliminates 4 here, so that's 8 and 4. That eliminates 8 here. We now have 6 digits remaining in row 2. And it has to be 2, 5, and 8. Again, this can't be 8 because of 8 in the box. That's 2 and 5. This can't be 2 because of 2 in the column, so it's 5 and 8. That leaves that as 2, 5, 8. Remaining digits, so we're guaranteed a 4 here. Remaining digits in column 7, we have 2, 5, and 8 again. And this can't be 2 or 8 because of 2 or 8 in the row, so that leaves a 5 there. That means this must be 2 or 8 here, but this can't be 8 because of 8 in the row. So this must be 2 here. That eliminates 2 here, so that's 5, which eliminates 5 here, so it's 8. No 5 or 8 here, that's 2. 2 eliminates 2 here, which leaves us a 5-8 pair here, and it eliminates 2 there, so that's a 4-8 pair there. 8 eliminates 8 here, so that's 4 and 8. This 5-8 pair eliminates 5 and 8 in the rest of the row, so this can't be 5, that's 2. In this upper central box, we have 7 digits defined, so the remaining digits are 8 and 9. Excuse me, this 8 eliminates 8 here, so that's 9 and 8. The remaining digits in column 5 then have to be 5 and 7, and it can't be 7 here because of 7 in the row, so that's 5, that's 7. We have 6 digits in row 3, which leaves us 4, 5, and 9. 4 cannot be either of these digits here because of 4 in the box, so 4 has to be there. That leaves us as a 5, 9 pair here. That means the remaining digits in this upper left-hand box must be 3 and 6. 6 can't be here because of 6 in the column, so that's 3, that's 6 there. That leaves a 1, 7 pair remaining in row 1. We have 6 digits set in row 5. So we have to have 1, 4, and 9 remaining. 1 cannot be here because of 1 in the box, so 1 has to be here. 4 can't be here because of 4 in the column. That leaves that as a 9, which makes that a 4. Okay. Okay, so in this right central box, we have 6 digits remaining. So it's 6, 7, and 8. This can't be 6, so this is 7 or 8, and we have 6, 7, 8 here as possibilities. And we have to find sets of 5. We have 5 digits to find, I should say. So let's just start going through those. Row 4, we could have 4, 5, 7, and 8. 4 and 8 can't be here because of 4 and 8 in the column. 7 can't be here because 7 and 8 here can't be here because of 7 and 8 in the column. This could be a lot of things. Remaining digits in row 6. We have 7, 8, and 9 because 6 can't be here. This can't be 8 because of 8 in the column. Row 8, we have 1, 4, 5, 7. 7 can't be here because of 7 in the box. 7 can't be here because of 7 in the column. Where is the 7 in row 8? It's there. 4 can't be here because of 4 in the box, so 4 has to be there then, which leaves us as a 1, 5 pair. Okay. Column 2. 4 eliminates 4 here, so that's 5. That eliminates 5 there, so it's 9, which makes that 5. 5 eliminates 5 here, so it's 7, which eliminates 7 here, so it's 9. No 7 or 9 here, so that's 8. So this leaves this as a 4. 7 eliminates 7 here, so that's 8, which eliminates 8 here, so it's 5 and 8. And eliminates 8 here. 5 eliminates 5 here, so it's 1 and 5. 1 eliminates 1 here, so it's 7 and 1. 7 eliminates 7 here, so it's 6 and 7. Remaining digit in column 2 is a 1, which makes this not 1, so it's 2 and 1 there. So we should be pretty much done. We have 8 2s. We know where the last 2 is. It's there. 3 in column 1 cannot be here. Oh, wait. It could be either of those spots. Dang it. Okay, well, where's 3 in column 9? It has to be here. That gives us 8 3s. That's 3 in the corner. We celebrate because we're close to solving this. We have 8 3s, so therefore the last 3 we know it has to be there. We have 9 4s. We have 8 5s, so we know where the last 5 is. It's there. We should have 8s. We know we don't. But we know where the 6 is in column 3. It can only be there. That gives us 8 6s, so the last 6 is there. We have 9 7s. We have 9 8s, and the last digits are 9s then. So that's 9 and 9 there. So, pretty straightforward. Yeah, I was mainly using this to introduce the even lots. You see this, well, it's not that common, I guess, but it's a decent amount of times, I guess, that you'll see it. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.